Okay, so we have question number 31 here. It says that a trough is 10 feet long and its ends have shapes of isosceles triangles that are 3 feet across at the top and has a height of 1 feet. If the trough is filled with water at a rate of 12 feet cubed per minute, how fast is the water level rising when the water is 6 inches deep? So I'm just going to draw the trough. And it's filling with water. And it says that it's 10 feet long. And the top of the isosceles triangle is 3 feet. And it has a height of 1 feet. Now this is just for the isosceles triangle. We want to know the height, how fast the water level is rising when the water is 6 inches deep. So this is going to be the height for it. Now we have that it is rising at a rate of 12 feet cubed per minute. That's going to be associated with the derivative of the volume, which is dV over dt. 12 feet cubed per minute. And then it wants to know the rate of the water level. So that's going to be the height. So dH dt. We want to know dH dt when the height is 6 inches. So that's 1/2 of a foot. It's best to put in the same unit so you don't get confused. Then we are going to need to find the equation. Now, since this is a triangular prism, we're going to need the volume of a triangular prism, which is V equals 1/2 times base times height times the length. Since we already have the length, which is just 10 feet, and we're trying to find the derivative of the height, we need to get rid of the base because we don't know what it is and it's not been given, so it's not asking for it. So how we're going to get rid of this is we're using the similar triangles concept here. So I'm just going to draw triangles, the base, this is the height. And then we're given that one of the isosceles triangles is 3 feet, and it has a height of 1 feet. And I'm just going to put them proportionate to each other. So base over height equals 3 over 1. Then I'm trying to find B so I can plug it back into this equation and get rid of it. So B equals 3 times H. I got that by multiplying H over, and then I'm just gonna plug this back into here like so. So it's gonna look like this times the length. Since we already know what the length is, which is 10 feet, I'm just gonna put that in there. And then we get, simplifying it, we get 1/2 times 30h squared. I got that by 3h times h, 3h squared times the 10, 30h squared. Then just going to simplify even further. Gets me 15h squared because I divided it by 2, 30h squared divided by 2. Then implicitly differentiate it. I get dv dt equals 30h dh dt. Once I got that by doing 15 times 2, the power rule, and then doing the chain rule on h gets me h times h prime dh dt. Then I'm going to find dh dt because that is what we're looking for. So dh dt equals, dv dt over 30h. I got that by dividing 30h over, like so. And then I'm just gonna plug stuff in. So that's gonna get me dh dt equals 12 feet cubed per minute all over 30 times the height, which we got here is 1/2 foot. Then we're just gonna simplify even further. It gets you 12 feet per minute all over 15. The reason why it's feet per minute and not like feet squared per minute is that this is basically just 30 feet. So if we did this together, that'd be 15 feet squared. Simplified it, that just left you with 1 feet on top. And if we simplify this down further, we get 4 feet per minute. If we were to put this in context, it would be the water level is rising at a rate of 4 feet per minute. And you can check your units by just going back onto the problems. 3 feet here, so we know that this is just essentially 3 feet times the height, and that's how you get that. Simplify that. Okay, thank you.